Hi, thanks for everybody who's joining the contributed session Q, New Methods in Macroeconomics. I'm Chris Kurtz. I'll briefly outline our plan for this morning. So again, thanks for joining us. There's 3 excellent papers being presented in session Q. We will have 20 minutes for each presentation, and then that will be followed by 10 minutes of Q&A. I think we have plenty of time to get through everybody's questions as well. So the papers that are being presented today will be by Pim Kasseleen, comparing imputation methods using expenditure surveys. Stefan Subrand, who'll be talking about macroeconomic data and transformations. And then I will be coming up at the end of this, talking about the business exit during the COVID-19 pandemic. So again, thank you everybody for joining, and we will start with the first presentation by Pim.
Yes, thank you, Christopher, for the lovely introduction. Let me see if I can start sharing my screen. It says you cannot start screen share while the other participant is sharing. Oh, there we go. Share screen. This one. And then let's go full screen. There we go. Yeah, so thank you once again to both Christopher for the lovely introduction and to the organization committee of this conference. Today I want to share with you some work that is titled Comparing Imputation Methods Using Expenditure Surveys and Unlinkable Administrative Data, with the subtitle and application to household consumption behavior in the Netherlands. So it's a little bit of a long-winded title. I think the project itself is multifaceted. It has 2 phases, and I will today abstract a little bit from the economic analysis and the interpretation of the results and focus more on the methodology that's happening, given the scope and aim of this conference. Before I get there, I do kind of want to embed this work into the broader research agenda I'm trying to work on. So the inspiration for this work very much comes from the new strains of macroeconomics, where there's a lot of attention paid to consumption heterogeneity. So a key variable in how macroeconomic behavior responds to shocks is attributed to the marginal propensity to consume out of wealth or income, and there's particular attention to balance sheet being important for the amplification of shocks. So you can think, for instance, of liquidity or leverage. So households have a lot of borrowing, and when they're hit by an adverse shock, they might not be able to respond as optimally as they would wish, because they are stuck with a big mortgage and a low housing value, or they don't have a lot of liquid assets, and therefore their consumption behavior might be pretty drastic. Now, there's been a lot of attention in this literature on the specific role of housing yielding this amplification of consumption behavior, and in the broader research agenda here, we try to pay a lot of attention also to pension fund savings and exhibit the Netherlands. So this research agenda kind of looks a bit more broader at the illiquidity of the asset portfolio of households. And in the Netherlands, households have to mandatorily participate in pension funds, and these are very illiquid assets. So this might mean that liquidity and leverage concerns are even more of an issue here. So if we kind of look at the data that we have, this is micro data from Statistics Netherlands. So this is the National Statistics Office, where we have the universe of Dutch households, and we do see a high prevalence of these kind of characteristics. So for instance, we see that 30% of households have liquid assets less than a month of their disposable income. We see a considerable portion of homeowners having a house that is worth less than the value of the outstanding mortgage. And we see that 73% of the working age face mandatory participation in pension fund systems. And crucially, not just poor people, quote unquote, are constrained in these kind of dimensions, but also very income-rich households have these kind of portfolios. So there's a lot of policy debate going on here, whether maybe the system is too rigid. So we see that households are primarily invested in these illiquid housing and pensions, and therefore have less liquidity and ability to smooth out shocks. So some of the arising policy questions here are, should the Dutch pension system be more flexible? And if we allow people to kind of withdraw early, or maybe voluntary participation or age-dependent contribution rates or voluntary contribution rates, what are the dangers to retirement saving adequacy? So I'm trying to work with some life cycle models to shed some light on these kind of questions, but I also try to employ some data. So this is where I think it becomes more interesting to the audience here. So the question of this paper is, can I use the data from Statistics Netherlands to say something about household consumption in the Netherlands, specifically thinking about these characteristics? So low cash on hand, high mortgage indebtedness, and mandatory pension fund contributions. And if we think about the data requirements that are here, they're pretty demanding. So I need joint information on both expenditures, income, and wealth. And I do have separately in different data sets, I do have access to these things, but still I'm suffering from some missing data. So there's an expenditure survey in the Netherlands, which has a lot of information on consumption, but doesn't really tell me much about income and wealth of households. On the other hand, I have administrative data based on tax records where I do observe pretty precisely what the income and wealth situations are of households, but no consumption. So I have to do some imputation in some way. And now the question of this presentation is, which way do I impute and which of the technique work? So I try one novel technique and one widely used imputation technique to fill data gaps. So in the first one, which is the novel one, I supplement the expenditure survey with this unlinkable administrative data that I have on income and wealth using the household matching. So I'm going to match households that are part of the expenditure survey and the unlinkable administrative data. And based on overlapping variables, I will show that I can pretty precisely identify these expenditure survey households in the administrative data. And I'm going to contrast these results, what I get when I simply take the administrative data and impute consumption there, so that's the missing data, using the household budget constraint, where we say that consumption is equal to disposable income minus a change in wealth. Now, I say unlinkable administrative data. I do have 1 year where I can match all these different data sets. So for 2015, I have the perfect link, so I can evaluate how these different imputation techniques are performing. And then I'll cautiously say something about these relationships between consumption, income, and housing, but I will not have time for that today. What I want to drive home as main findings are that this household matching works pretty well, and I'll try to leave at the end a short overview of when I think it can add some value. And I will show also that the consumption imputation implies way different saving rates than what is reported in these expenditure surveys. So there's a bit of a consumption puzzle still to be resolved. And both imputation techniques broadly identify higher marginal propensities to consume for these constrained households. Now, definitely not the first one here, and out of courtesy, I put down a whole bunch of papers. If you're in the literature, you'll be familiar. So there are some methodological ones. People have been comparing this kind of consumption imputation using the budget constraint with expenditure surveys, mostly in Scandinavian countries. And there's been a lot of economic applications using these procedures. Now, let's have an overview of the data that I have. The administrative data is available from 2011 to 2018. On the universe of Dutch households. So these are constructed from tax returns and municipality registers, and these are all different linkable data sets on household characteristics, income, assets, liabilities, residential location, but crucially, no measure of consumption or expenditures is here. Now, I have the expenditure survey that has different waves. So in recent years, it has only been conducted in 2012-13, where it was unlinkable with the administrative data, and 2015, where it was linkable. And so the order of magnitude here is not in the millions of observations, but only in the thousands. And these are very typical expenditure surveys where households are recording their purchases in diaries, and at the end of the year, they fill in some additional questionnaires. Crucially, what's important is that I don't have detailed information on income and wealth. So let's look at this first imputation technique where I enrich the expenditure survey. So I add income and wealth information into the consumption survey. So since the expenditure survey households are part of the universe of Dutch households, they must be a part of the administrative data, and I have pretty highly specific information on these households. So I can match these expenditure survey households to administrative data households using these overlapping variables. So the type of variables that I have at my disposal that overlap, that have similar definitions are, for instance, categorical variables, such as the composition of the household, age cohort, municipality code, primary sources of income, and also some continuous variables where I apply some bandwidths. So income, value of the house, paid interest on mortgage, etc. So this is crucially different from the Skinner regression prediction technique, where typically the CEX was used to impute consumption into the PSID survey, where you would regress consumption on overlapping variables and extrapolate. Since we really can narrowly identify these expenditure survey households in the unlinkable administrative data, we really focus on these overlapping variables. So we match these expenditure survey households to one or a multiple administrative data households based on these overlapping variables. And if we look at the overlap with these overlapping variables, whether their variables have the same value, they overlap between 81 and 99%. So they are pretty congruent with each other. And using the various different sets of these matching variables, in our baseline scenario, we can match 85% of households to at least one household in the administrative data. And of those matches, 80% we can have correct identification. So we match on average, or as a median, 2 of these administrative data households per expenditure survey household. And using these continuous variables, we take the mean or we take the closest fit, we try different things, it all yields similar results. So there are some concerns here whether there's sample selection. So I don't really want to, this graph looks a bit daunting here. What I want to show with this is that there's not really any concerns of sample selection. So it's not that certain type of households are more easily matched in the administrative data versus other ones. These histograms, the green and the red ones, show similar distributions. That's the broad picture I want to show with this imposing figures. Now, we do see that on the median, we have pretty small errors for the imputed values. So for instance, if you look in the yellow bars here, for instance, for disposable income on a yearly, at a yearly frequency, we're off by a couple €100, and the median error, absolute error is pretty low for some other variables, but we do see that we are off considerably at the tail of the distribution. So the worst thing that can happen with these matching is that households are similar in terms of these overlapping variables, but very dissimilar along these other characteristics. So we're matching a household that looks the same, but it has completely different bank account balances, for instance. So in the median, we're doing pretty well, but we are stuck with some very large outliers where it's very difficult to correct for. Now, what's the antidote to this? What's the other imputation technique that we're using? So we're exploiting the household budget constraint in the administrative data. So here is, again, the household budget constraint. It looks a little bit different here. So we have on the left-hand side total expenditures being equal to disposable income minus the return corrected change in assets and liabilities. So the reason why we have to correct for the returns on assets and liabilities, we can think of stocks here, for instance. We see that we observe at the start of the year and at the end of the year the total value of the portfolio, and we cannot simply take the difference to tell us anything about consumption. If we wouldn't correct for returns, it would imply that appreciation of assets implies this saving, or no consumption. Sorry. So returns do not constitute consumption, whereas changes in quantity, so purchasing additional of these assets or liabilities, does constitute consumption. So we don't observe these household-specific returns, and so we have to do some educated guesswork here to kind of arrive at our measure of expenditures. Now, if we look at the imputation error, so simply taking the difference between what we impute and what we observe in the expenditure survey, we see a very persistent difference. So if we regress one on the other, we see a pretty linear fit. But if we plot the histogram, we see that the expenditure survey is very much to the left of the imputation. And so these imputation errors, they're correlated with characteristics that resemble a more complicated balance sheet of households. So this is to be expected. This is where return correction will be less precise, but you see very much that consumption rates are very different. So if we plot here, for instance, we see that the implied consumption rates, so consumption is a ratio of disposable income, according to the administrative data, 30% of households consume between 90 to 110% of their income every year, while this is only 8% according to the expenditure survey. So ideally, all the histogram would be in between these two red bars, but you see that the majority is way lower than that. So something in the expenditure survey implies that consumption is very low. Now, there's been some concerns in the fact that we don't really observe everything about interest-only mortgages. So in the Netherlands, 60% of Dutch households have an interest-only mortgage that are often coupled with pledged savings accounts, and these are not recorded, or at least were not until literally last week. So what we see here, if we don't observe these pledged savings accounts, we overestimate consumption. we don't record the accrual of assets through these pledged savings accounts, while the value of the mortgage is not being paid off. And so therefore we might overestimate consumption. Now, I've tried to assess whether this is very important or not, whether this might explain the fact that these consumption rates are so different between the two data sources. So we try to identify the IO mortgages if the nominal value of the mortgage is constant over time. So it's implying that the household is not paying back the mortgage. And we do see that actually there is no difference. So whether we have on the left-hand side households with likely interest-only mortgages, on the right-hand side households with a mortgage that has some degree of amortization, it's still very much the same, that the imputed measure of consumption is still way higher than what is in the expenditure survey. So we're still left with some kind of a puzzle here. Now, let's have some short discussion in the last final minutes on these two different regression or imputation measures. So moving on later in the paper, I will not bore you with the details. We do this very typical Campbell and Coco regression model where you relate changes to consumption to changes in income and housing, interacting it with these indicators of liquidity and leverage and mandatory pension contributions. And we see that we get similar results using both data sets. So whether we use the expenditure survey or the administrative data, we get similar results and find that higher marginal propensities to consume are there for constrained households. Despite these similar results, what I want to conclude here is that there's still very significant differences. So with this expenditure survey, we have a lot of information on consumption, and so therefore we can really precisely estimate non-durable consumption, whereas with the imputation approach of consumption using the household budget constraint, we only observe total expenditures. So of course, expenditures are not the same as actual consumption, especially for durable goods. So there is some difference here. We can disentangle these two using the survey, but not with the administrative data. The administrative data seems pretty strong overall though. So with the survey, we're not observing the same households over time. So we have a repeated cross-section. So this makes regressions a bit more tricky with cohort regressions and stuff like that. Whereas the admin data is a true panel, and we have millions of observations instead of thousands. And so there's kind of like, how wrong is our imputation? Well, the imputation into the expenditure survey, we have small median errors, but large outliers. With the administrative data, we seem to consistently be off the mark in our consumption, so large median errors, but not really any large outliers either. So we kind of have like two wrongs. The both imputation measures are very imprecise. And so I think when this household matching works very well is when this survey information is crucial. So enriching external data sets based on overlapping variables can work very well if this expenditure survey has information that otherwise you might not be able to get. So in our application, the difference between non-durable consumption and total expenditures doesn't really turn out to do much, or doesn't really matter too much for the results. But you can imagine, for instance, if you have a survey on household expectations or households, you're very interested in certain consumption patterns, then enriching these expenditure surveys with external data sets based on overlapping variables might work well. Now, lastly, the question is, which of these two consumption measures are wrong? So are we either misallocating these returns in the consumption imputation with the administrative data, or is there simply underreporting in these spending diaries? And so this has been a long-standing debate where it's very difficult to kind of reconcile, which of these imputation methods are to be preferred and what is actually wrong. So are we actually comparing a truth against some imputed measure, or to which extent are we comparing two measures with very big observation error? So I think I want to conclude by kind of saying that overall it's pretty difficult, I think, to do these imputations, to really know whether what you're doing makes a lot of sense. So I highly welcome and point you towards some new advances in this literature where people are using bank account transaction data. So Ganong and Noel, for instance, did this with some data on unemployment, where people, they could really observe spending behavior, income behavior, and wealth behavior based on these bank account informations. And this has also been used for some research in response to COVID-19 hitting. So for instance, Bouni et al. 2020 had some French bank account data where you really have a joint measure where you don't need to impute anything and can really in a timely fashion kind of do the regressions that you want to do, where you have a data set where you have consumption, income, and wealth. So kind of advertising other people's work based on my kind of pessimistic impressions of the results of this work. But yeah, that's where I wanted to leave it. So happy to address any questions or remarks. And yeah, that's it. So thank you for your attention.
Thanks, Pim. I'm just going to open the floor to any questions. And I guess I'll start with one question or two questions in a way, is that you showed the errors at the 95th percentile. Were they larger or smaller when you were thinking about, let's say, the 5th percentile? Because I could imagine when you're more, when you're focused on sort of hand-to-mouth consumption, that it might be more the kind of lower end of the distribution in which those deviations might matter more.
So what we do in this table is I take the absolute errors. So I take the entire distribution. So it would be interesting to see if there's some asymmetry here in the errors. I think I did look at that. It's been some time ago, so I should check that out for sure. I think that's a good consideration. So here I just put the absolute error. So if you just say being off the mark, be it below or above, is wrong, then that's kind of why I showed the table as I did. But I will for sure check whether there's some asymmetry, because if I don't really on the lower end I don't really observe these things going wrong, then indeed it might make the results more believable later down the line with the regression. So I think this is a great point. Yes, thank you.
Thanks. And I'm looking at the Q&A. So if anybody has any questions, please feel free to add them. And I should have said this earlier, but I'll probably, I mean, Pim was just perfectly on time, but I'll probably shout out a 2-minute warning if we get close to the 20 minutes for a talk. Does anybody else have any relevant questions? I think this is really interesting. And I think the debate between survey and administrative data just keeps coming back up over and over again. So it's nice kind of seeing the signals from the two combined.
Yeah, cool. We can move on. If there are still any questions, people can put them down in the chat or the Q&A, and if they do pop up later, then we might return there.
I think we just got one from Marshall. I don't know if you can see it.
Yeah, I can see it.
Mute. Hello. Yeah, my question was, there might be some uses of income that aren't covered by the Consumer Expenditure Survey, which would maybe help to explain the gap. If there's, say, gifts to others or charity or maybe interest. So maybe there's just some missing uses of income on the Consumer Expenditure Survey.
Yeah, I think this is a great point. So I do know what I recall that they have these kind of identification codes. So there's this European code on different consumption spending patterns that all these households kind of have to adhere to. And so gifts are there. I don't know if households are likely to report them. Interest expenses are also, I think, likely to be misreported. They do have to report what they spend on their mortgage. So you kind of don't really know whether that's paying off the mortgage or paying interest. So I kind of do know that. But I mean, in this survey, I think also the reason why it has been so infrequent, so it was there in 2012, 13, and then in 15 it had a revamp. Then it went to a 5-year frequency. So it should kind of return this year with data from 2020. But that's likely to be affected due to COVID. So it's very difficult to kind of make use of this consumption survey. And in 2015, there were these additional data questions at the end of the year asking people about their holidays and other big purchases. So I think in 2012 and 13, especially, many households were not really kind of reporting their most durable consumption. And so indeed, there is some reason to believe why there is a shortfall, that the consumption rates might be too low in the expenditure survey rather than the the spending rates are too low in the expenditure survey, and it might actually be that the imputation is more on the mark.
Very good, thank you.
Thanks for the question.
All right, thanks all. If there are no more questions, we'll move to our next paper. And it's always good to have papers that talk about things that matter. And this will be focusing on macroeconomic data transformations and saying that, discussing how important they are. So I will turn the floor over to Stefan. Thank you.
To unmute. Sorry, I was muted. All right. So I'm glad to be here today presenting the paper, Macroeconomic Data Transformation Matters. That's some joint work realized with Philippe Boulet-Coulon, Maxime Lowe, and Dalibor Stefanovic. So today what I'm going to be doing is I'm going to go over some of the motivation and goals behind the paper, present some of the candidate transformations that we're considering in this paper. And then I'm going to showcase the horse race setup that we use to tease out the marginal contributions that each of these candidate transformations might have on forecasting performances on macroeconomic data at various horizons. And then I'm going to discuss some of the key results of the paper and hopefully have some time to conclude. Now, there's a very ample literature that has grown in the past decade on the presence and the possibility of making accuracy gains along different types of metrics when you're conducting forecasting, whether in macroeconomics or finance, using machine learning algorithm. I've put there some of the more recent paper, but there's many other. I could fill up quite a few slides with that. But what we're interested here today is not so much the algorithms themselves, but what happens when you change what you put in those algorithms when you're conducting your forecasting experiments. And there's basically two lines of two directions where you might think there could be gains to be had in this sense. One of them is when you're looking at macroeconomic data transformations, typically what you're looking at are efforts to remove some of the low frequency movements in the data. So you're thinking about correcting for unit roots. So you're imposing a sort of linear or log linear restriction in how permanent changes build up in the data. Maybe it's an overkill. Maybe you're dealing with data that's not really non-stationary and you're transforming it, taking growth rates and whatnot. Or maybe there's nonlinear integration either between variables or variables in themselves over time. So that's one possibility, and it might be suboptimal for machine learning. In principle, maybe it can learn on its own how to disentangle the long-term and short-term movements in there. Another line of thought is, well, when you're dealing with macroeconomic data, you're looking at relatively short data sets and pretty noisy macroeconomic indicators. And so even though one of the primary motivation behind using highly nonlinear and flexible algorithms is to try to benefit from some sort of self-engineering of features where the algorithm themselves are complicated enough to extract the signals, you may nonetheless prefer to automate those, to not automate all the transformations and do them manually beforehand to help your algorithm identify what's going on. So that's the direction we're taking in this paper. So we're proposing to look at new or less common ways to encode what we call time series friendly priors into machine learning models. And basically what this means, well, priors translate into regularization and frequentist perspective. And basically when you transform the input data that you feed into algorithms, you're changing how they impose those regulation on the data, how they shrink the data and so on. And basically, we're trying to take stock of the fact that we're dealing with time series data to do it. Now, throughout the paper, most of the paper is actually focusing on the transformations that you apply to the predictors rather than the target. The target in any event is always, we want to forecast an average growth rate over H months. And the two ways in which you might be wanting to do this is either you model it directly or you model an entire path going to the H month. So you do all the month-to-month changes and you take an average. And we're going to be considering that direction as well. Now, what kind of compromises arise when you're trying to think about feature engineering or data transformations? Well, in this picture, HT, that's your raw data. In your case, that's going to be FredMD. So it's log level data or data in levels that's not been transformed. And FZ are either one type or many types of transformations. So maybe you're taking growth rate because you want covariance stationary regressors. Maybe you're leaving them in levels, or maybe you're taking out factors. We're going to be looking at different FZs, basically. And then you input those transformed data into an algorithm that selects a function G, following as a solution to a penalized least square kind of problem. And when you're doing this, you're essentially looking at two types of errors. If you want to look at the simple way to have an intuition about that, if you take all the transformation that we're using in the paper and do a sort of kitchen sink type of regression, well, you might have a sense that even if you input stuff that's completely irrelevant, at least the model could potentially tease out what's interesting. So you have a lower approximation error to the true data generating process. But if you do input stuff that's irrelevant, you're going to be increasing the estimation error. And the whole paper is about how do you choose FZs or a combination of FZs so that you get a good balance between these things in terms of mean squared errors for forecasting accuracy. So we consider older or more common candidates. There's the obvious case of, well, I've got data that might not be, or in some case clearly isn't covariance stationary. So you take differences in levels or logarithms of growth rates and these kinds of things. That's going to be what we call X. Another very common thing to do is once you've got a panel that you believe is covariance stationary, you're going to use principal components to extract the linear latent factors from the data set. That's been very popular since the work of Stock and Watson, Bai and Yang. Another possibility that's often used, more so in the structural literature, but you could use the series directly in log levels or levels, depending on which series. So we do that. And we also consider less common candidates. This one called moving average rotation of X. It's essentially inspired by literature in the 60s and 70s on distributed lag models. And their intuition was to try to find ways to have a sequence of coefficient in those models that progresses smoothly. So the paper that we use as a grounding word for that is Schiller, 1973. It's basically the idea is you set up a ridge regression, and instead of shrinking your coefficients to 0, you shrink the coefficient to the previous one. So b to p to p minus 1 and so on. It turns out, and we show it in the paper, if you play a bit with the problem, you're going to realize that what you're essentially doing is you're constructing modified regressors, where the new regressors are basically moving averages of variables that you find in your covariance stationary panel. So that's one of the things we do. We take different orders of moving averages of each variables and use them as regressors. Another less usual transformation, perhaps less usual for people in macroeconomics, but not so much for people who work in computer science, is what we call the moving average factors. So one idea that you might have, you take every variable in your data set and say, oh, I'm going to take a bunch of lags that variable. And I'm going to try to extract a variance maximizing component from it. So you apply PCA on what we call the transition matrix, so that lagging matrix for each variable, trying to extract signals that best explain the movement at different windows of time. And maybe that's going to help you achieve better forecasts. And I said it's not too unusual for certain types of researchers, because there's a type of tool that we call singular spectrum analysis, where they would be taking the whole common component of the linear factor models. So basically the MT times the gamma K prime, they would take the estimate of that whole thing. And you could use the structure to directly produce forecasting from there. But what we're doing is we're extracting an estimate of the MT and using these things as regressors in our prediction problem. So to summarize, what we're looking at is 5 transformations here. 5 transformation here. In the paper, if you go towards the end, there's a little section where we consider other transformations, taking the square of X, extracting PCA component from X, the Farney and all dynamic factors, and there's things Bangery and all in 2014, they had a way to account using factors, a way to account for possible co-integrating vectors. So we're looking at these transformations as well, but in the interest of time, I'm going to be focusing on the main transformation here. The models we're using here, we're trying to cover some of the typical types of transformations you're going to see in the literature. So you've got the autoregression and the factor model. Factor model, that would be the diffusion index type model of Stock and Watson. We're using this as a reference, as a benchmark, to have an idea of how the other ones are performing. We also have an adaptive lasso, elastic neck, linear boosting, random forest, and boosted trees. So the horse race, what are we doing? Well, we're using direct forecast. It's very common when you're using nonlinear algorithms. Otherwise, you have a problem with the Jensen's inequality. You have to work a little harder to find the optimal forecast. So we're not iterating on the structure of models. We're simply directly forecasting everything. The reference data, the data we use is FredMD. We've got different targets. 10 variables. We're trying to span a real income activity, the more consumption sides too, and some more monetary nominal variables in there. Oops. All right. We're looking at different horizons, spanning all the way from 1 month to 24 months. We use a very long pseudo-auto sample period, going from January 1980 to December 2017. And we estimate everything using the expanding window. So in the paper, if you go look in the appendices, you're gonna find we have all the Debo-Marino, we have the model confidence sets, and of course we have some of the regression framework we're gonna see in a minute. But here's a table where we take in every single case the very best model. So what works best? And here, what's underlined are models where it's worth modeling the entire path for the change over H months instead of doing it directly. So, and obviously that's only meaningful for months, for horizons greater than a month. What we get out of this picture, and it's actually borne out when you do the analysis more formally, the first thing is there are green dots almost everywhere. So using factors to condense information from large data sets, that works wonderfully well. Another common results you get out of this table, the random forest, RF, and boosted trees, the BT, it's appearing everywhere. So using nonlinear algorithm usually pays out. There are a couple cases, very consistent cases, namely in the production side. So if you're looking at the production, the employment, so the real activity variables, you're going to see a lot of the use of marks, the moving average rotation. So when you're using moving averages of different orders from your data set, that helps. And there are many cases where it's actually useful to have many transformations. And something that might be somewhat surprising to some people, there's lots of blue dots. So it's actually useful to use the raw data directly in levels in those circumstances. So what are we doing in the rest of the paper? We're trying to test more formally how different transformations contribute to the explanatory power. The way we do this is we collect the forecasting errors out of the sample. We build pseudo R-squares out of them, and we run fixed effect regressions in pairs of horizon variables to see what seems to work and what doesn't. Throughout, we're going to be looking at some results in that, and throughout, we're using HAC consistent standard errors in those regressions. So what are some of the main findings? If you're looking at the moving average rotations, it's very potent, especially for real activity and especially in combinations with nonlinear models. Here, we're going to be looking at a few of those graphs in the last 5 minutes of presentation. The way to read those is the vertical line is zero effect. And what's good for the transformation, that is when there are gains, the dots are on the right of that. So if you want to look at the real activity, that's the blue and the green. So you see here with the nonlinear models, you've got some statistically significant effect, and you're looking in the range of 10%, maybe 15 some cases. So it's not negligible effects. It tends to help. It rarely hurts. It does in some cases, but it tends to help. The other thing that's interesting is it seems to have gains that take up in the aftermath of the recession. So basically, the red line is what you want to be looking at, and here it's just two particular cases where when you exit as you go in and exit the recession, the jump is larger in other methods when you're neglecting marks. So it seems to be capturing some of that dynamic of moving out of recessions. And there, the factors, they help a lot when you use nonlinear models. We saw the green dots, that's preserved. There seems to be a lot of what we call uncertainty around the estimates. You see the error bands are pretty large, but there are some cases, surprisingly interesting cases, very large effects here at longer horizons. There are some tiny effects at lower horizons. It rarely hurts. There's a few points where it's statistically significant and large, and then on the negative side, but it usually helps to use factors. So that's a common result here. The other thing that's interesting, result that's going against some of the work by Medeiros and all. That team has a paper published in the GBS where they concluded that factors have marginal contributions when you're trying to predict inflation. One of the things that we do differently is first, the target's slightly different, but we actually consider the case of where we're restricting the model to use only factors. And we see here, the best thing to do when you're predicting inflation in this context seems to be to just use the factor. So that's an interesting result in this context. And one of the more, the moving average factors results a little more muted. But there are some cases where it seems to help. So it's worth considering when you're trying to figure out what kind of model you want to use for macroeconomic forecasting. And perhaps the most surprising results of the paper is this one. Why is it surprising? Well, look at the dots on the right side. It's very, very, very clear. There are some cases where the dots are really on the zero line, or the band cover the zero line, so the effect is not significant, but there are many cases where it's actually significant. So up to an horizon of 12 months, and that's perhaps one of the most clear result of the paper, that sometimes it's worth modeling the entire path, predicting the entire path of the changes over the next 12 months instead of, say, predicting over the next 12 months. Same thing at 3, 6, and 9 months. Why would it work? Basically, that's my last remark here. We have an idea in the paper. We've got a little toy model where we explain the intuition. Basically, if the best signals that you could use to predict a variable changes per horizon, that is, you've got model composition, heterogeneity across horizons, that's the time where if you try to use a direct approach where you predict the entire difference in one step, you actually have a denser, harder problem to learn. And it would be easier and probably works out better if you modeled every change per month separately and added them up. There is some suggestive evidence in the paper that this is exactly what happens. With the random forest algorithm, you can tease out the variable importance and see that indeed when there's a lot of model composition heterogeneity, that's when it works. And when all the models at all horizons seems to be weighing in the same way on the same types of transformations, that's when it doesn't matter. So basically, some of the new transformations seems to help, especially marks at this. Sorry, that was the alarm. So especially marks in combination of with nonlinear algorithms, factors almost always useful, barely ever cost you something to put them in. And in many cases, surprisingly, it's worth to model the entire path of changes. And I'll stop now.
Thanks. That was really interesting. I'd say that I really think the result where the significance and increases as the time horizon goes out is quite fascinating. I would add one, I guess, just kind of question / recommendation is that I noticed that industrial production seemed to not have as many different successful models per se, and I would say that maybe one way of kind of thinking about that is that focusing on just manufacturing might give you a different result, because industrial production would be utilities, mining, and manufacturing, and maybe those other like kind of utilities and mining might be more subject to kind of random shocks in the weather and just kind of elements related to extraction, mineral extraction and whatnot. So kind of the economic signal is typically more found in the kind of manufacturing portion of that. But thanks very much for an interesting presentation. Any questions?
I think we've got the question from Gary Kook. It says, another approach would be to put all the different transformation into a single model and allow the machine learning. All right. Well, we tried this. I guess I forgot to point it out, or I pointed it out too fast. We consider cases where we're combining a bunch of transformations, and we do the kitchen sink thing for some of the transformations, not the newer that we have in a low section at the end, but we do kitchen sink kind of thing. And if you go back to the presentation, remember the table with the best models. When there's many dots, it means it's all in the model. So there are cases where there are 4 or 5 transformations at the same time in the best model. Just to give you an idea, when we have all these transformations and things, there's a case where the best model includes something like 3,000 regressors. So yes, sometimes it's worth putting everything in. But we do suspect that when you put everything in some cases like the inflation, that's when you're kind of drowning the contribution of some of those things. So there are cases where the kitchen sink is not going to help you. And it has something to do with like random forest having trouble to tease out which variables to keep and which variables to omit when the regressors are really tightly correlated.
Thank you.
I think you just got another question.
Oh. Karem Tuzquogulu, or I'm sorry if I massacred your name. Does transformation marks make sense? Usually there are rebounding effects in macros. So with respect, the sign of betas to flip after a while. Yeah, that's a concern. If you have an idea of a dynamic model, go ahead if you want to.
I was just going to say, Kareem, I've just put them off mute. So if you wanted to add anything else to that question, Kareem.
Thank you. But I think he got it already correctly, the question. Thank you very much.
Okay, so that's a concern. Obviously, you've got some dynamic systems where the whole properties, it's going to bounce around up and down, right? So maybe there are some cases where marks doesn't work too well because of that. But there are cases where it seems, assuming the smoothness in the transition, the coefficient works. That would be something to explore if there's a way to meaningfully encode your intuition a priori before inputting the information in the model. That could be an avenue to explore to extend the results in the paper. Gary Coop asked also about forecasting tails. We didn't do it on in that paper, but we are revising a different paper where one of the extension include interval and density forecasts. When you're using nonlinear algorithms like random forest, you can modify the basic algorithm meaningfully to have consistent in-sample estimation loss function that you're optimizing to select your subset. So you don't do like the Mainhouse and all paper from 2006 where you use the basic Bremen algorithm. You do something different like the Susanate kind of approach. He has the package and art to do it. We do that. It seems that it's worth inputting the factors in those models as well. But we didn't do a case where we're varying all the inputs. We basically did the Stockin-Watson diffusion index model for tails in a quantile type of random forest.
Perfect. There are no more questions. Thank you very much, Stefan.
Sorry, I had a question.
Oh,
I'm just unmuted. Sorry.
Karam is back.
A quick one. Yeah. So the direct approach working worse, could it be possible that some of your estimation techniques are not that robust to maybe moving averages that are left in the errors? That might be, one interpretation. Because the further ahead is, t plus h, it means that you introduce much more important or significant moving average in the errors.
Mm-hmm.
And
yes.
maybe your estimation techniques are not robust to that. And
yeah, when you're using a direct approach, you have a problem of overlapping forecasts.
Yeah.
So it creates autocorrelation by construction. Yeah, the standard errors that we use in the estimation are HAC. So they correct for that in principle. Okay. So if there is positive autocorrelation, they'd be wider, and if there's negative, they would be tighter, presumably. So.
Okay, thank you.
Excellent. Thanks, Karen. And then a great presentation, Stefan. Now I'll say it, if there are no more questions, we'll move on to our final presentation, which would be me.
Yeah, take it away, Christopher.
All right, so thank you, everybody. And thanks to the organizers of the conference. So I'm going to be talking about business exits during the COVID-19 pandemic, specifically talking about non-traditional measures of business exit. And I think, kind of one of the important takeaway points of this conversation is going to be putting measures in historical context is going to be important, and making sure that we can compare non-traditional measures to their recent trends is also going to be really valuable. I think if there's one thing you could take away from this talk, or one thing I'd like you to take away from this talk, it would be that, surprisingly, for the last year, given everything that's happening, the business exit picture does not seem to be as bad as expected. So what we're going to I'm going to briefly review where I'm going. So, did business exits surge in 2020? I think there was this general idea, and I subscribe to it, that there would be sort of this small business and business apocalypse during the pandemic, particularly just due to kind of lockdowns and businesses losing all their customers for months at end. An important thing that comes up when we're thinking about this is where do the official statistical data point to, and where are they going to take us? They're the gold standard for tracking the economy. Unfortunately, the official data on 2020 business exit patterns, it's going to lag substantially, which is really sort of pushing to this idea that we need non-traditional data to help answer some of these questions, particularly when you're thinking about the importance of, say, policy responses in the midst of the pandemic. So the BLS has information I'm going to discuss in a bit, but essentially their business exit data doesn't show up until late 2021, and firm exit that comes from the Census Bureau, that information is not going to show up until 2023. It's important just to kind of revisit something we all know, which is that these big data, this non-traditional or alternative data, has played a really critical role in tracking the pandemic. In a lot of cases, it can complement, not replace, official data. There's been a lot of reports of widespread exit based on these non-traditional data sources. But, kind of jumping back to that theme I mentioned, is really need this historical context when people point to home-based data as saying 35% of small businesses remain closed using an alternative or non-traditional data source. It's really important for us to understand, what does that mean? What does 35% of small businesses remaining closed mean? And what I mean by that is that we need to understand that data source and what the traditional attrition is in these data sources. So I'm going to think about that point of regular attrition, and then also present some of these historical facts on business exit. So kind of an outline for where I'm going. I'm going to discuss these key stylized facts. I'm going to provide an update using the BED data. I'll talk about ADP payroll processing information, discuss some of the more popular non-traditional data sources, monthly and home-based, use cell phone location data to present a metric of business exit, talk a bit about indirect measures, and then tie it all up with some discussion of forward-looking survey measures. So importantly, though, let's get a few concepts and some terminology out there. Again, going to this gold standard, that is the traditional data sources. Both the BLS and Census publish statistics on business closure and death. The BLS publishes establishment data through the BED, Business Employment Dynamics Program. That's at the quarterly frequency. And like I said earlier, in late 2021, we will see the exit information for the second quarter of 2020. The census also publishes exit data. This is annual through the BDS, or the Business Dynamics Statistics Program. And this will be for both firms and establishments, as opposed to the BLS information, which is focusing on the establishment. But one difference is this is at the annual frequency. And then, primarily for the ADP data that I'm going to be talking about in a minute, which is a payroll processor, the kind of role of shutdowns in that. You could have organizations permanently go out of business, and then also temporarily suspend business. And for kind of, the definition of exit actually matters. So how do you think about an exit? And we'll have different definitions of exit in these different metrics. But I think one of the best ones to think about would be sort of the BLS would say, you're closed if you haven't made an employee payment if you haven't had an employee for 3 months, And but you're in exit if that happens, if that same situation is occurring for 4 consecutive quarters. Let's turn to the BED again, where 1 quarter of no pay would be your closure and 4 quarters of consecutive no paying employees would be a business exit. What these figures are presenting are essentially the unweighted and employee weighted rate of closure and death. And so one thing that just sort of jump out at you is that the unweighted numbers are significantly higher. You're seeing quarterly exit rates of about 5% over the past few years. But once you weight those numbers, you'll see that the quarterly closure rates are about 1% over the past 5-10 years. And that means that essentially as you employment weight these factors or these exit rates, you're going to see that a lot of the churn is happening in extremely small establishments in this case. And that matters because sometimes you'll think that these exit rates might not have large implications for the overall economy. And that's because it's happening once you employment weight it. You see these things are happening for those organizations that are relatively small. I don't mention it in this talk, but the paper provides those same rates for different size classifications. And you'll see a lot of that exit is happening at the really small establishments, really those kind of less than 5 employees, less than 10 employees. The BED data is based on data that underlie the quarterly sense of employment and wages. Temporary closure is common. Like I said, is affecting about 2% of establishments or about 0.5% of employment each quarter. And the way I get to that 2% and 0.5% is really the difference between the red dashed line and the blue lines. Now let's look at the census sourced information. Again, this is the annual information. A brilliant aspect of the census information is that it provides these metrics for both establishments and firms. Again, we see a lot of churn. Establishment death is actually quite common. 8.5% of establishments exit annually. When you compare sort of the left and right panels again, you're going to see the same story I told a second ago with the BED data, which is that this sort of churn, these exits and closures are happening a lot for those smaller businesses. And so let's kind of take a step back and think about what's the cyclicality of exit. And so when you think about business cycle code movements, and this is in state level data, you're just going to see that exit is countercyclical. Maybe that's not surprising to most people, but I think the literature really hasn't kind of come down and used this stylized fact as much as it should. So just kind of making the point that exit is countercyclical, and it's not just with unemployment. You can use the same kind of time series analysis to show that we see countercyclical exits for unemployment, GDP, and industrial production. And then you can kind of go within states to see that same cyclicality. So what are the takeaway points before we kind of move into the discussion of these non-traditional measures and some of the recent information we have on business exit? Well, let's keep in mind that annual firm exit rates are about 7.5%. Annual establishment exit rates are about 8.5%. That affects about 2 to 3.5% of employees, depending on whether you're looking at firms or establishments. Quarterly establishment exit rates are about 2.5%. And temporary closure is extremely common. I mean, it's about 2% of establishments per quarter. And again, kind of repeating what I just said in the previous slide, is that exit is countercyclical. And so, but that second to last point, I'm just going to reiterate that if temporary closure is common and it affects about 2% of establishments per quarter, then we really have to be mindful of that number when we think about what type of closures we saw in the second and third quarter, or first, second, and third quarters of 2020. So I'm going to quickly jump to an update on Q3 BED data. We talk about Q all the way through Q2 in the paper, and I would say kind of look at some of the details of that if you want to kind of see how we come up with these numbers. But if you're looking at the most recent BED data, then you're going to see an increase in exit rates in the second quarter. And I have this by establishments employment and just those rates. The latest data is indicating about 600,000 total deaths, and with a few assumptions like half of deaths might actually be temporary reopenings, then you're going to come up with about 150,000 excess deaths, and those excess deaths would be over the establishment deaths, which you would see in general, which is about 225,000 a quarter. So over the first and second quarters of 2020, we're coming up with about 150,000 excess deaths, and keep that number in the back of your mind because we're going to return to that. Now let's talk about some of these non-traditional measures that I mentioned, and the first one is going to be ADP payroll data on exit. Really what we're doing is we're measuring the share of businesses closed by duration, and we can weight these by different measures, and we can really just focus on those organizations. We're looking at micro data on payroll, and we can say that if a company has not issued paychecks, that they're probably closed. It's important, again, to kind of use the entire time series of information to have a basis of comparison. So we calculate the difference of those not making payroll to the average share from 2015 to 2019. And it's important to take away, and this was surprising when we first ran some of these, when we first did this analysis in the middle of last year, because shutdowns were extremely elevated, but they quickly kind of returned to normal. And let's kind of look at pictures that make that point. So there's little evidence of excess exit. And what we see here is essentially the deviation from kind of the normal non-payroll, or the normal share of businesses that are not making payroll for different time periods, so 25, 36, and 70 days. And you'll see that quickly that deviation jumps up to about 12% in April and May, and starts heading down by June. And really by the time we hit August, the share of businesses closed returns to normal, and actually kind of falls below what you'd see in terms of the normal quantity of businesses or share of business that weren't making payroll. So quite a surprising result when we first saw it, but I think the rest of the information we're going to walk through today is going to reinforce this idea that the share of businesses that aren't making payroll or that are not open anymore is actually not surprisingly elevated. The next slide repeats the similar analysis in terms of the deviations of those that are not making payroll for different size classes in different industries, and that's analyzed a little bit more in detail in the paper. What I want to do next is jump to sort of these small business trackers, and two of them that have kind of been in a lot of different media and academic discussions have come from Womply and Homebase. Womply is a credit card transaction processor. And really, this is where kind of you'll see the discussions focusing on extremely small businesses, and large sort of closure rates are being passed about in these conversations. Homebase is a clock in, clock out tracker. But what is really important here is that it's really important to compare sort of these numbers that we're seeing through 2020 to the usual attrition rates in these kind of platforms. So, and that's not something you can do with Womply because there isn't previous information on previous years to kind of compare that to. So, you're going to look at those numbers and see that for, say, leisure and hospitality, about 50% of businesses aren't making transactions anymore. That's alarming. And the same thing would jump out of Homebase. And the Homebase figure here shows a solid blue line and a dashed blue line. And what you'll see discussed in many places is that about 35% of those small businesses aren't making payroll anymore. And that's alarming. But if you realize, when compare that to the sort of attrition rate that you'd see in 2019 at about 30%, then we're looking at more like a 3% deviation from normal attrition by the time we hit March of 2021, which is not as surprising. So for small businesses, definitely elevated closure relative to previous years, but not 35% elevated, just about 3% when you compare it to normal attrition. The next thing I'm going to discuss is saying kind of moving from some of these small business trackers and the payroll information to using what I think is a pretty non-standard approach to kind of measuring business exit, and that's measuring closure based on consumer traffic. So really what we have here and there's a lot of details and kind of different robustness approaches to this presented in the paper, is thinking about measuring closure based on those cell phones that visit different establishments. And I mean establishments here because this is based on location and a specific business. So it's not a whole firm, it's an establishment. SafeGraph is the company that provides this information that we're using, and it's really just an aggregator. It anonymizes the geolocation data from cell phones. Roughly 45 million mobile devices are employed here. We have about 6 million points of interest. This is used, you'll see the SafeGraph information used for lots of different metrics, such as thinking about staying home, different types of establishments that are being visited by industry, what's happening to barbershop visits and different services. There's some drawbacks. I think it's really tough to think about longitudinal consistency. There's lots of changes when new devices get added to their sample. And, just like some of these other data sources, there's not enough history to think about kind of proper benchmarking or really analyzing how these time series behave. And it's not applicable to all businesses and industries, because you can think that in some cases, if you don't have a fixed address, say you're a food truck, we're not going to be able to know, be able to track over time how your establishment is doing. So here's results of temporary closure. We define temporary closure as defined as a year-over-year drop of 65% or more in terms of actual visits. We can use sort of actual minimum and maximum visits to kind of check these results. But really what we see is a really dramatic increase in the percent of restaurants that are temporarily closed in March and April. And those temporary closure kind of percents fall over time, increase again as we kind of hit another wave of the pandemic in November, December, and have come down again. And we've also done things like compare these results for establishments that we've known have closed, and it looks like what we're thinking when you look at an individual sort of reporting establishment. And it's also discipline based on some SafeGraph information that they have on temporary closures. More importantly, when we think about this and moving from temporary closures to permanent closure, you'll see that we have a monthly rate of permanent closure. Permanent closure is not that complicated here. We're just saying that it's a temporary closure that never reopens. So you'll see some revisions over time, let's say as organizations or as establishments reopen. So there is revision, particularly in the most recent data. And it's also disciplined a bit by some open close status. And you'll see that there are people out there trying to kind of list businesses that have closed. And I think some of that information is taken on board here, but we see, elevated for dine-in restaurants, we see pretty elevated closure rates, a cumulative of about 13.5% since the start of the pandemic. I think more, importantly, not just looking at restaurants, we take this information and then we look at all, we look at different industries, and it also aligns well with expectations. There's a nice discussion of sort of thinking about some of the industries where we're seeing elevated closure relative to the average and relative to the Great Recession. So what this does is this kind of takes the census BDS data and sets sort of a 2015 to 2018 average. And the blue bars are really saying, what are we seeing in those sectors relative to the historical average and what we've seen in the Great Recession. So you'll see for things like personal care, automotive repair, much higher elevated exit rates relative to history. And in other sectors, the exit rates are actually lower for, say, things like electronics and appliance stores. It's lower than the average and lower than the Great Recession. So we kind of go through, combine different sources of data to come up with an estimate of what we think the implications are for the total economy as a whole. And less is misspelled there, but we're finding about less than 200,000 excess deaths in 2020, which is in line with the BEP data that I discussed earlier. So there's some other indirect measures I want to point to here. Things like small business delinquency rates, office and retail vacancies. These are really they were elevated for a bit, and in some cases still are. Also looked at things like business electricity accounts, internet accounts, Google searches for going out of business, and these have all kind of made sense over time, and in some cases point to still elevated rates, but in many situations, it also shows that sort of things have kind of moved back a little bit more towards normal. I'm going to take in some survey evidence right here and talk about expectations of permanent closure and the need to obtain external finance. And this comes from the Census Small Business Pulse Survey, kind of just a little forecast. I think if you go to contributed session S, Kathy Buffington is going to talk about the Small Business Pulse Survey in more detail. It's been able to provide some high frequency, really important kind of data on what's happening in the small business part of the economy. So to jump to the left-hand figure here, you're going to see that expectations of exit in the next 6 months were elevated in the first 2 waves of the Pulse survey, and then really kind of came down in the new year. And you'll see the red dashed line is the historical rate of exit in the next over a 6-month time period. So you'll see that essentially that throughout the pandemic, it was elevated and then kind of moved down more recently. And that might be consistent with this idea that a lot of organizations no longer needed finance. And in an interesting aspect of this too, is that the largest improvement we saw in this comes from kind of arts, entertainment, and recreation, which we know received a lot of kind of supplemental funds through the PPP program that came back at the turn of the year. And consistent with this idea that you kind of don't need external finance anymore. So let me wrap this up and say, let's take some stock of business exits and say, again, returning to the overall kind of message I want you to take away is that contrary to most of the other discussions and narratives we've had over the past year, the business exits has not been as elevated as we expected, but it is elevated among restaurants and small businesses related in specific industries, particularly industries that have a lot of personal contact. There's also indirect evidence of credit delinquencies, and for a while, Google searches for bankruptcies were elevated. Commercial real estate vacancies, remain elevated. But again, like, it's important to note that the business exit overall doesn't account for a lot of employment, and we're seeing this in the really small businesses. And the latest data from the BD and Pulse surveys are somewhat positive. So we might end up, in a situation where there's not as much actual exit, and we'll see this when the official data comes out. And that would be a plus side of this. But I think there's also some larger GE questions to take into account here, whether or not in the next few years we might see more elevated exit for businesses that were able to kind of obtain funding and survive the pandemic, but then never kind of renormalize. So thank you all very much.
Thank you, Christopher, for the very showing a wealth of data and information, all these kind of different metrics. Very interesting. I think the first question in the Q&A ties into exactly that topic. So let's see if Andreas Joseph can be unmuted to ask his question.
Hi, Chris. Great presentation. I really enjoyed it a lot. Sorry, I came a couple of minutes late, so if you said something I already answered my question, then apologies for this. So I was thinking that this could be even more powerful if you try, if it's of course possible, to merge those data sets. Because, for example, I thought your payslip analysis could also be interpreted as that some of this payment is kind of smoothed over across the year, because sometimes the dips at the end of the year seem partially offsetting the kind of shortfalls like at the beginning. There could also be some government support be involved there, so it's not clear if this all led to direct business closure. But for example, merging this with say store visits data, I guess one could come to like a very convincing story. Thank you.
Thanks, Andy. That's I think that's really kind of where this type of work should go, in the direction of sort of being able to answer the question of what actually caused this from different data sources. There's some of my colleagues in a different group that are using the payroll data and matching that to recipients of PPP to see how that's impacted their employment. And we're seeing that there are some substantial results on that end. That large quantities of, like, how do I want to say this? There's an important employment effect to the recipients, and kind of that is related to organizations that might not have closed but could have. But I think a lot more work needs to be done in that direction. It's explicitly related to less just the employment effects and more towards the kind of closure effects. And that sort of ties into my last point, which is what are we going to see in the next 2 years as some of these recipients might end up kind of re-emerging in a different landscape, and then maybe the business is no longer sustainable. Thank you.
So there is 2 questions being asked in the chat. One is by Arthur, which I think you can directly address where the slides are available. And I think Josh Martin is more of a substantive question, so perhaps he can be unmuted to ask his question on communicating the lags in official data based on ONS experience.
Hi, yeah, thanks very much. So at the ONS, we've launched a couple of new experimental indicators on business births and deaths over the course of the pandemic. One is a weekly indicator from which we source from Companies House, which is the sort of the register of legally registered companies in the UK, and that's just the total number of incorporations and dissolutions of businesses, or companies, I should say. And then another is a quarterly indicator from our business register of the number of additions and removals of businesses on that register. Both have shown an uptick in incorporations, but not much increase in business deaths. We think largely because of the lags, both sort of legal and statistical lags in recording those deaths. And we've had a challenge communicating that with people who are expecting to see those deaths come through, as you were alluding to at the beginning. I just wondered if you had any thoughts on the best way to communicate those lags and what we can do to explain the environment and the landscape without sort of detracting from the trust that people place in those statistics.
Yeah, I think it's almost like we're, and maybe I'm going to veer a little bit too far from what your question is, but it's almost like we weren't, in many ways, we were not prepared for the environment that we faced in early 2020, but a lot of focus has been on entrants. And when you think about dynamism, that people are thinking about like what's new businesses, what, you know, they're productive. They're the ones that sort of end up, or the successful ones are productive. They're the ones that end up hiring a lot. And that's a really important part. And I think there's been a lot of progress made on measuring the entrants. And I think it's fascinating. I really want to look into that weekly indicator, because on this side of the pond, you know, we've had the weekly business formation statistics, which has been hugely integral. And it also kind of uses tax registration for EIN applications and kind of predicts what the rate of new entry is. And that was also extremely surprising at a certain point when we saw sort of this jump in business formation as measured, you know, at that time by applications for EINs, because it was kind of counter to some of these discussions that you're just seeing this kind of diaspora of businesses and no new, you know, everybody's kind of hunkering down. And one dimension on entrance was showing a very different story, which we think is consistent kind of with the lack of exits in some ways. You know, I think communicating the lags it's a problem. And I think sort of maybe this new focus on how important exits are might lead to updating business registers in a more timely manner. But I think just unfortunately, just by the nature, even with the BED data, which is, you know, it's lagged, but, you know, not only is it lagged in terms of the release of the information, but, you know, how you define business exit is, you know, it takes time. If you really have to wait 4 quarters to find out whether an exit really happened, then, you know, it's lagged just by the measure, not just by the data collection. I think that's why leaning on some of these non-standard indicators has been important from our side, and sort of entering that into discussions from our principals, say governors, or in the public documents that the Fed has produced to sort of point towards these indicators. And then just engaging the research community to kind of push back, just like, you know, my discussion about that 35% exit rate is just, you know, having that discussion is really important. And in some cases, then at least, you know, in this work, when it gets picked up in the media and discussed on that side, it's surprising. And then it does kind of change the narrative. I just think, you know, it's also the case that this sort of communicating the lags sort of retains that trust. it's just unfortunate that in some cases, once the lags pass and the information comes out there, that interest might have been passed. But I think it's just the biggest problem that is being confronted right now in terms of these lags and kind of retaining the integrity of the official data. I hope that answered your question. Probably too much.
I think it just echoed the concerns that we have as well, but thanks.
And to Arthur's point, I can email you the slides, and but I think we'll also have a mechanism of having them posted, I think, after this talk to the ESCoE website, which will be great.
Yeah, I do believe that the slides should become available. So for those people in the final dying minutes, please feel free to still submit any other questions in the Q&A box or in the chat that you might have. Perhaps tying in with the latest remark by Josh Martin about these non-standard in-the-moment measures. Do you maybe see other areas where this approach could be applied preemptively in case another shock requires data in the moment? So with COVID, there was a lot of shutdown of businesses, so it's very kind of appealing to start thinking directly about business exits. Do you see any other, doing this work, have you seen any other potential applications for this kind of more kind of philosophy or approach in getting data in the moment?
I would just say that I've been incredibly impressed with a lot of companies' willingness to share, this information, which some might think is proprietary, with policymakers to kind of help make better decisions. And I think that spirit arose during the pandemic, and also just the reflexiveness of our statistical agencies, like to put out really timely, high frequency information to kind of help policymakers. It's really heartening, I think, in the situation that we've confronted, as negative as it is, to see, a lot of academics and policymakers and private companies kind of come together to present information that has been extremely helpful for kind of guiding us through the past year, and hopefully helping us guide us out of the next few months.
I think that's a very heartwarming message of global friendship here and collaboration. So if there are no, there is, I think, one more question by Andreas Joseph in the chat. So if you could please be unmuted.
Hi again. I was just thinking of the business dynamism point, and I think what we could aim. I mean, now lags are still a problem, but for example, use this kind of multidimensional microdata to maybe learn about how business entry and exit looks like across different dimensions, and then first try to reconstruct events, but also then for the future have like more real-time indicators that one tells you, if I see this pattern in a certain business or industry, I'm likely that more guys are coming in or out. Thank you.
No, I think that's a great, once we get the official data in hand, to actually use sort of a ML framework to put together a great predictor that kind of works in real time. And now that we have these other indicators in hand, and once we get the official data, that should be really useful going forward. And I think that'll be a fantastic exercise.
Yes, thank you.
Okay, let's leave it there. So if people still have some kind of questions or discussions remaining, I'm sure they'll be able to find the contact details of all the presenters during the session. I will also point you towards the coffee break discussions that are due to start in 2 minutes. So feel free to go ahead and continue the conversation there. For now, thank you all for being here, being an interactive audience. And hope to see you in other discussions later today. Thank you.